We are in AP Calculus AB. Today's date, for the record, is Tuesday, March 10th, 2020. This is going to be the key for worksheet 11-2. Let's jump right in. We have function on the top, function on the bottom, and it gives us our functions there and there. And find the area of the enclosed, find the area of the shaded region enclosed by the graphs. So we don't even need to find the intersection point because it tells us it's 1. So our integral is going to be between 0 and 1. Let's write it down. Our integral between 0 and 1. And why are you writing down the integral, Mr. Sindel? Because you can just do it on your calculator. You get points on the AP test if you write down the correct integral, as Arrow has learned very hard. That's a hard lesson. Okay, so this is going to be, I'm just going to write f of x minus g of x because I'm lazy. And how do, plus f of x plus g of x?
Yeah.
You're always going to do top minus bottom, 100% of the time.
But
you're trying to find the shaded region, so
it
goes
it's a
below.
negative area.
So I could go like this. I could say f of x, and then I could add this region over here, but that region is going to be minus, so I'm going to have to subtract that region, g of x.
Okay.
So it's the same thing either way. And as a general rule of thumb, that equation, f of x minus g of x, top minus bottom, is going to work regardless of where you are, below or above the x-axis. Yeah, that's a good question. I should have made that clear in the notes. That's all going to be multiplied by dx, the thickness of those slices. Coming to our calculator to program those. Again, I had to be careful here. The f of x was the top function. How did I know that? Because it's labeled. Haha. All right, so from here, y equals, and I'm going to type in 2x in parentheses, 1 minus x. And then my y2 function is going to be my g of x, my 3 times the quantity of x minus 1. I could have distributed that 3 right there. Oh, and then multiply by the square root, so second x squared of x. Cool, so we have both of those functions. They look good. Second quit. I'm going to now go math 9, integral of vars right, enter 1 minus vars right, enter 2. And I realize that's kind of unnecessary. I could have just typed in 2x times x, 1 minus x minus all that function. I didn't have to put them in y1 and y2. I'm so used to doing that because I want to find their intersection points. That's with respect to x from 0 to 1. And my answer key is saying 1.1333. This is doing its thing. It's taking its time. I'm going to write down the answer that I have from last year. I'm going to assume it's correct. I got 1.133. Calculator, did you catch up? You did. Thank you. And notice it's not 3 repeating. Maybe there's some weird error. I don't know. Cool. I'm going to box it and move on to the next problem. Notice there's no unit, so I don't have to worry about that yet. Find the area of R. Okay, function f is on the top, and I don't know what this intersection point over here is for its x-coordinate. I'm going to figure that out first. So I'm going to plug in both these equations into my calculator to find that intersection point. So my top function is going to be my y1. Always make your top y1 so you don't get confused. If you accidentally say, oh, I'm going to put g of x in my y1, then you're going to have to do y2 minus y1. It'll be a slightly different procedure. You might lose a point. You might lose all of your points if you start off the problem wrong to begin with. So be warned. Sine of 2x, and then my next function is going to be my e to the power of x divided by 2. Cool. I don't need it in parentheses, but I'm going to do it because it looks cool. And then I'm going to do window. Oh, I have no idea. I'm going to guess my window is going to be between 0 and, I don't know, 5. Ooh, 2. Go to. I'm going to guess between 0 and 5. I'm just totally guessing. It could be 10. It could be 0.5. No idea. And I'm going to go zoom 0. Let's see. How close was Mr. Sindel? Well, I know because I can look at the answer key. The intersection is 1.136, so it's going to happen right about there for the intersection. Ooh, that's kind of a cool, oh, it's a sine wave, that's why. And yeah, it happens right there. It doesn't matter what my window was, you can still find it as long as you can visualize where it is. So how do I find that intersection? I'm going to go second trace to calculate the intersection point, so 5. And my first curve, enter, enter. There's only 2 curves here, and my guess is 1. And it looks like it's going to be, as I said, 1.136, rounding. So in my notes, I'm going to label 1.136. And now I set up my integral. So it goes from 0, because that's the first intersection point. It's pretty clearly at the y-intercept. So my integral is going to be between 0 and 1.136 of my f of x minus my g of x. And then all that thing dx. All right, so time to do it on the calculator. So I'm going to quit out of this thing. I'm going to do math 9. I'm going to do Vars right, enter, enter, minus vars right, enter 2 with respect to x from 0 to 1.136. And my answer key is saying 0.429, and this one caught up to me really quickly. 0.429 is equal to 0.429, and I box it. Ooh, there we go. We finally get some double things. So with each section, I need a separate integral. That's the main thing to know from this problem. We have f of x, which is on the top on one, but on the bottom for the other, which is the reason that you have to separate it into two different integrals. I'll label this as well. This is an f of x here, and this is a g of x here, and then they eventually switch. So f of x is then on the top for s. We need to find the area of r. Typically they say, what is the area of this entire thing, and you have to separate it. Well, it's already separating it for us. Just find r. R is with g of x on the top, so be careful how you say this. As a general rule, if you're ever doing area in between two curves, your answer is always going to be positive. If you get a negative answer, that's because you switched the integrand pieces. So our integral is going to be between what and, oh, we don't know the intersection point. So I don't know what that is, so I'm going to say it's between 0 and that thing that I don't know. Let's find it. So I come back over here. Let's go to my y equals and clear both of these functions. My y1 function is going to be, ooh, should I make it g of x or f of x? I don't know. I'm going to make it f of x because f comes before g in the alphabet. That's how I made that choice. Just remember which choice you make. So it's going to be slightly backwards for my first integral on the calculator. I'm going to do 1 divided by 4. Or I could have just done 0.25. It doesn't matter. 0.25 plus sine of pi x, so second to the power of for pi x. And my second function is going to be 4 to the power of negative x. Cool. So I'll quit out of this. I don't know. I could guess 10 here. I think 5 is an okay guess. I'm looking at my answer key. It's actually 1. So I'm going to do, I could have done window 0 to 5 again and zoom 0. Notice that we have to find both of these intersection points. I didn't say that before, but both this point and this point are not labeled on our graph, so we need to find it. Unless, okay, this is kind of cool too. I remember this from the pre-test/test. Sometimes they tell you not on the graph, but in the problem where those points intersect. Don't do too much work. Read the problem. Sometimes they tell you down here. We do know who typically makes that mistake. Okay, so it looks like we're just talking about this integral over here on the left. So if I wanted to make it slightly more accurate, I could do my window from 0 to like, I don't know, 1.2 or something, and then, ooh, not trace. No, trace works too. But it's going to be off now, isn't it? No? Oh, it'll look really nice. Okay. And we can see, oh yeah, that definitely looks like that graph. I have the two different regions there. So let's find that first intersection point. I do second trace to calculate the intersection, so 5, and enter first and second curve. My guess, so this guess is important. If I guess like 0.25, I'll get that intersection. If I guess 1, I'll get that intersection. So the guess is the only thing that distinguishes the two intersection points. So I'm going to guess 0.25. Oh yeah, if your window is like weird, then obviously you can't see the one, right? There are no bounds for this one. All you have to choose the first graph, the second graph, and then a guess. Yeah, so this intersection is 0.178. Let's label that 0.178. And then the second intersection point, again, second trace to calculate, hit 5, the intersection, enter. My guess now is going to be 1. And, oh, the intersection is exactly at 1. So 1.000. All right, we have all of our bounds now. Let's come back to writing our integral. This integral is going to be between 0 and 0.178. And be careful now. It's always top minus bottom. The top here is g of x minus the bottom, f of x. And remember that we did f as y1, so it's going to be y2 minus y1 when I'm doing this on my calculator, for the first one at least, for the area of r. S will be a little bit different. So second mode, to quit out of this thing, let's clear the screen. I'm going to do math 9, the integral of vars right, enter 2, my y2 minus my vars right, enter 1, my y1. Okay, all with respect to x, from 0 to this 0.178, and I get 0.065, rounding. 0.065, and I'm going to get rid of this circle so it doesn't mess me up for my notes when I save them. And then finally, the area of S, this is going to be the integral between now 0.178 and 1, or 1.000 if you prefer. And this is not going to be g of x minus f of x. It's now f of x minus g of x. Again, it's top minus bottom. The top is now f. not G. All right, so let's do that on our calculator. I'm just going to, I can't hit second enter because it's basically the same thing. So I'm going to do math 9, vars right, enter 1, so it's y1 now instead of y2 first. And then this is going to be vars right, enter 2. With respect to x from 0.178 to 1, so comma 1. And I get 0.410. So this is going to be equal to, oh, I want to do it in black, is equal to 0.410. That's a bad 0. And then I'm going to box both of those. Have I been labeling my problem numbers? I have not. Bad, Mr. Sindel. All right, so this is problem number 1. That's problem number 2. This was problem number 3 that we just finished right there. I'm on to problem number 4 down here. By the way, in terms of the timing of the class, we have 12 minutes left. Number 4, we have this thing. Are we allowed to use calculator? No, let's get rid of this thing. Bye, calculator. It's nice knowing you. All right. So, did you already do 4 with the calculator? Cheater!
5.
Okay. Find the area of R. Okay, so this clearly is y equals 6 on the top. Why do I know that? Because y equals 6 is a horizontal line, and then the curvy line is the non-straight one, aka the 2 square root of x. Yeah, I know I quit you. Wait, I didn't want to reopen. Go away. Go away. Okay, this is 2 square root of x. Find this area of R. Well, it's going to be top minus bottom. So it's going to be the integral between where and where. Luckily, it tells us what the x-coordinate is. And it's the x-coordinate, not the y-coordinate. Don't make that mistake. The x-coordinate is 9. So 0 to 9, and our integral is going to be top, which is 6, minus the bottom. The bottom is 2 square root of x. And then all that thing dx. All right, now we've changed the problem from a graphical, what is this area, to solve this integral, this definite integral. So how do we do that? Well, first you take the antiderivative. So taking the antiderivative, well, I guess we have to change this x, square root of x to x to the power of 1/2. That helps us to take the integral, or the antiderivative. So antiderivative of 6 is 6x. Antiderivative of 2x to the 1/2 is, so I'm going to do minus 2. It turns into x to the power of 3 halves, right? 3 halves. And then I divide down, so times 2/3. And then that's going to be evaluation bar from, what do we say, from 0 to 9. 0 to 9. I should really be looking at the key so I don't make any mistakes while I'm doing this. Looks like I'm good so far. And from here, I'm going to start plugging things in. How much room do I have? I have plenty of room. Okay, so this is going to be equal to, if I plug in 9 first, it's going to be 6 times 9. So 6 times plugging in that 9. Minus, okay, this is really 4/3, so 4/3, and then I'm plugging in 9 right here to the power of 3 halves. Okay, that's what happens when I plug in 9. What happens if I plug in something else, like 0? So if I plug in 0, I get 6 times 0, that's 0, and then minus 0 to the power of 3 halves is 0, times all that is still 0. So all that's 0, I don't really have to do anything. So I'm just going to leave this as minus 0 to let you know that, yes, I did plug in 0, and there it is. Now I just have to simplify all this stuff in green. And the hardest part now is, what is 9 to the power of 3 halves? So let me do some scratch work off to the side. What is this? I'll do it in blue. What is 9 to the power of 3 halves? If you don't know how to do this, here's your reminder. It's really 9 to the 1/2 to the power of 3, which is the same thing as the square root of 9 to the power of 3, which is 3 to the power of 3, which is, did I run out of room? Dang it, is equal to 27. Let me move all this stuff over to the left. Haha, technology, which is equal to 27. So 9 to the power of 3 halves is 27, which means this 9 to the 3 halves is 27. So I can do a little arrow that says that goes to 27. And then I can say, oh, 27 divided by 3, that's 9, and then 9 times 4 is 36. So this all together right here, I can do a curly brace, this all together is 36. And then 6 times 9, we know that's 54, so this is now equal to 54 minus 36. And 54 minus 36 is 18. Final answer, and box it. Whew, yeah, without a calculator, you have to do a lot more work, don't we? We still have 2 more problems to do. So that was number 4. We're on to number 5. Number 5. Let's zoom out so we can see what's actually happening here. We have this R, which is a tiny little sliver of a region. We have y equals square root of x and y equals x over 2. Which function is which? Well, x over 2 is a line. It's linear. So x over 2 must be the bottom piece. And then square root of x is the non-line, the non-linear. And it's the square root. Okay, so we have the top, we have the bottom. We have the x-coordinate of the intercepts, 0 and 4, so we're ready to go. Let's start doing this. I have the integral between 0 and 4 of the top. Top is square root of x. square root of x. The bottom is x over 2. Okay, all that thing, dx. Here we go. I've turned that problem from a graphical what is happening to a definite integral. Antiderivative. Well, again, you think of the square root of x as x to the 1/2. So when I do that, I now take the antiderivative and it's x to the power of 3/2, and then divide down by 3/2 and it's 2/3. All right, antiderivative of this, you can really think of this as 1/2 of x. So antiderivative is I should do the minus sign too, 1/2 of x to the power of, move it over a little bit, x to the power of 2, and then divide down, so another 1/2. And don't forget, it's not plus c, it's evaluation bar because it's a definite integral from 0 to 4. Next, okay, I can kind of simplify that. That's really a 4 on the bottom. And yeah, start plugging things in. Notice when we plug in 0, nothing is going to happen. So 0 squared is 0, 0 to the power of 3/2 is 0. So I don't really have to worry about the 0. I just have to worry about plugging in 4. Plugging in 4, I have 2/3 of 4 to the power of 3/2 minus 1/4 of that 4 squared. All right, so 4 to the power of 3/2, again, we'll do some scratch work, and I'll save some room now. 4 to the power of 3/2 is really, I'm skipping some steps now, the square root of 4 cubed, which is 2 cubed, which is 8. So I say this thing right here, that turns into 8. And 8 times 2 is 16, and 16 divided by 3, I'm just going to leave that as 16 divided by 3, 16/3. And then from there, I am going to multiply, okay, well, 4, I have 2 4s on the top, 1 4 on the bottom. I'm just going to cross 1 off from each, and I just am left with 4, so minus 4. That's the answer, but I need to simplify it just a little bit more. I'm going to multiply 4 by 3 over 3, and I'm going to get 12. 16 minus 12 is 4, so this is equal to 4/3. And again, don't have to worry about units. Done. Whew, we're almost done, and we have 5.5 minutes left of class. So that was number 5. We're on to number 6. We can finish the homework in class. Nothing to worry about tonight, hopefully. All right, so we have shade and region R bounded by y is equal to x squared, and it even tells us which function is which. But if you couldn't tell, you hopefully should know how to do it anyway. So the shown figure above, find the area of R, top minus bottom. Here we go. It is the integral from, where to where though? It doesn't have any of the x intercepts, or the x points where it intersects each other. So how do we find those? Set them equal to each other. If I set them equal to each other, x squared is equal to 4. Take the square root of that, take the square root of both sides, square root, and I get x is equal to plus or minus 2. And that's why we have a negative 2 there and a positive 2 there. So my integration is really going to be between negative 2 and 2. So negative 2 and 2 of our functions. Top is 4, bottom is x squared, and all that thing is going to be multiplied by dx, the thickness of each of those slices. All right, so looks good so far. Let's go ahead and do our definite integral now. So taking the antiderivative. Antiderivative of 4 is 4x. Antiderivative of x to the power of 2 is x to the power of 3. It goes up a power, divide down, and those are being subtracted. This is going to be evaluation bar between negative 2 and 2, plugging these guys in. I have 4 times 2 minus 2 to the power of 3. Let me give some room here so I can say 2 to the power of 3, all divided by 3. That's what happens when we plug in positive 2. We need to also plug in this negative 2. So I'm going to say minus in parentheses. The second thing should always have parentheses because it is going to need to distribute this negative. Let me see the problem. It's 4 times that negative 2. So 4 times that negative 2 minus that negative 2 to the power of 3, all divided by 3. All right, time to simplify these guys. This is now going to be equal to 8 minus 8/3, and then I'm going to distribute this negative, so there's lots of negatives happening. A negative times a negative is a positive, so I have a positive 8 now. This is a positive right here, times a negative is a negative, so I have a negative 8/3. And you might be saying, you have the same thing twice. And there's another way of doing this problem that I want to talk about before the class ends, but it's really twice of whatever that is, so I am going to do that. What is this? I'm going to simplify and say this is really 2 times whatever 8 minus 8/3 is. And we'll talk about y in a sec. And that's going to be equal to, well, I have to multiply that 8 by 3 over 3, right? So that's going to be 8 times 3 is 24. It's 2 times 24/3 minus 8/3. And that is going to be 24 minus 8 is 16 thirds, and double 16 thirds is 32 thirds. So our final answer here is 32 thirds. So there's a cool trick that I want to teach you guys about when it comes to integrals, and especially graphical integrals. Check this out. If you have the same area on the right and the same area on the left, you can make this problem easier on yourself, and I can do this. So our original definite integral looked like this. You could have gone 2 times the integral from 0 to 2 of 4 minus x squared. These two are one and the same, judging by the symmetry of the graph. So I'm going to type this out. I'm going to say that this right here, I'm going to change the font here to 14. This is okay because of the symmetry. It has to symmetry of the graph. And smiley face. Cool. And I'll draw an arrow, a Claire, to that integral right there, so we know that for the notes. And we are done with worksheet 11-2.